everyone, myself Karimunnisa Shaik. I am from Mlritm. Today the topic is OS services and structures and system calls. Let's coming to the session. These are the list of contents: structures of OS, simple structure, layered structure, OS services and system calls. In simple structure, this is the diagram. In simple structure, it contains application program and resident program, MS-DOS device driver, ROM BIOS device driver. It is a simple structure. These do not have well-defined structure, are simple, and limited interface is well-defined. This is a one interface. Application program is a one interface. Resident system program one interface. MS device driver one interface. ROM BIOS device driver is a one of the interface. Here, application program is directly connected to the device driver and resident program is directly connected to the device driver. Each and every interface is directly connected to the device driver. That is the drawback. Next, each and every interface is well defined, but structure is not well defined. In this, the example is MS-DOS. In MS-DOS, application programs are able to access basic IO routines. Application program is directly accessed to the ROM BIOS driver and the resident program is directly accessed to the ROM BIOS device drivers, and device drivers is directly connected to the ROM BIOS device driver. In this, the drawback is it is very complicated, no clear boundaries between the modules, and data hiding is not there in this structure. Next, advantages of the simple structure is it delivers the better application performs because of the few interfaces between the application program and hardware. It is easy for kernel developer to develop such an OS because if anything is need to change in application program, we change in the application program interface itself only. So this is the simple structure. Next, coming to the layer structure. In the layer structures, the OS is broken into the pieces. Here the example is we have seen. We have to see example. Here the layers is divided into 0, 1 and n. Here 0 layer is the hardware and n layer is the user interface. In one layer 1 contains file management, and application program interface, here each and every layer contains the assigning tasks. Here in this structure, OS is broken into number of layer or levels. The bottom layer is 0, that is hardware. This is the 0 and this is the hardware. And the topmost layer n is user interface. This is the topmost layer, user interface. Next, these layers are so designed that each layer uses the functions of the lower level layers, simply debugging process. If any error occur in the layer, if we need to change the error or rectify the error in that layer only, but identifying the error should be we need to access each and every layer. After that, we get the error. Then error must be on that layer only. Here lower level layers are debugged and an error occurs during debugging. Then the error must be on that layer only, as the lower level layers have already debugged. Here if any modifications is to be done in that layer, we need to change the layer and or we need to change that layer only. If I need to change the modifications in layer 1, it does not affect on the layer 0 and layer n. That is the advantage. Next, layer makes it easier to enhance the OS, as the implementation of layer can be changed easily. changed easily without affecting the other layers. If I need to change the layer 1, if I need to change the layer 1 or modify the layer 1, I need to modify. By modifying the layer 1, it does not affect on the layer 2, layer 2 and layer n, layer 0. That is the advantage. Next, the disadvantages of the layer structure. The application's performance is degraded as compared to simple structure. It requires careful planning for designing the layers, as the higher layers use the functionalities of the lower layer. This is the disadvantage. Next, the services of the OS. OS provides some services to the users. Next, what are the services provided by the OS is which we have to see in the next slide. Services provides the, for what purpose services provided by the OS is enrollment of execution process in an efficient and convenient manner for user. Enrollment of execution process in an efficient, convenient manner. For user purpose, if user need to execute a program, that should be efficient and convenient to the user. In that purpose, we are using OS services. Let's see what are the services are there. Some of the common OS services are there. Program execution, input-output operations, communication process between the processes. Next, file management, memory management, resource allocation, error detection. Here these are the common OS services. Here first one is the program OS. Whatever the program executed or whatever the program which we are executed that was loaded into the memory by OS, it is allocated for the execution process to CPU. Here, and finally user gets the result through output devices. Here the program is saved in the secondary memory. While opening that program, it opens on main memory. That program sent to the CPU for execution. Who sends the CPU? OS. OS selects the job or process from OS selects the job or process from main memory and sent to the CPU for execution. For program execution, for whole program execution, the services provided by the OS is program execution. This is one of the service. Whatever the program which we saves in the system or secondary memory, that will be executed or functioning by the program execution. This service is provided by the OS. Next, input-output operations. OS system manages the input-output operations and establish the communication between the user and device drivers. Here, the user is giving input. Whatever the input which we have given, that will be executed and the concerned output will be displayed on monitor or whatever the device. If we need to give some inputs, that can be executed and output will be come from the output devices. Next, the whole input and output operations can be functioning by the input output operations. Next, communication between the processes. What is mean by communication? Communication is nothing but exchanging the information. Exchanging the information between the processors. How it can be done in, we have to see. First one is it can be done in two types. First one is the shared memory and second one is the message passing. In shared memory, here P1 is there, here process 1 sends to a message to shared memory and P2. Here, whatever the message we have to send, that can be sent through the shared memory. Here, the shared memory is sent to the process 2. Here, two processes are there. One process sends a request and shared memory sent to the processes another process. Here, the mediator is shared memory. Through the shared memory only, message sending will be there. Here, whatever the message, whatever the request we send to the processes P2, that can be after it can get the request from processes or shared memory. It will send the response to shared memory. After sending the response to shared memory sends to the processes P1. Here this is the shared memory. Next, in message passing, here directly communication between the process 1 and process 2. Whatever the message we need to send by P2, that after for that message the reply can be done in processes P1, sent to the P1. Okay, this is the message passing. Next, in file management, what is meant by file? File is nothing but collection of records and entities. Here, if a program needs to access a file, it is the OS and grants access these permissions: read only, write, read and write, etc. It also provides the platform for users create, delete, append and copy, rewrite, read, write, paste. These are the file operations is there, and modify. These are the modification. These are the operations can be done by the file management. These functioning, whatever the files functioning that can be done by the OS on file management services provided by the file management. Next, in memory management, we have two types of memories. First one is the primary memory and second one is the secondary memory. In primary memory, it is also called as temporary memory. Temporary memory is which is not permanent. Here, secondary memory is permanent memory. If the primary memory or main memory contains two parts. First one is the OS and the second one is the user space. Whatever the program which we have given by the OS on particular time, that can be done, execution can be done through OS only. Here main memory contains two parts. First one is the OS and the second one is the user space. In secondary memory also contains two parts. First one is the OS and the second one is the user space. The secondary memory is the permanent memory, which the files can be stored in the disk drives. Those are the. Here, the OS selects the job and sent to the CPU for execution. Whatever the files for we need to do execution, that files can be saved on secondary memory. Next, the next service is resource allocation. Here, the CPU scheduling algorithms are used to allocate the resources for execution of the programs. Okay, here we have the CPU scheduling. CPU scheduling is nothing but while executing the program, the scheduler, CPU scheduling contains a scheduler. Scheduler is nothing but the programs should be executed in a particular time. That can be done by the scheduler only. Whenever the program is executed, the execution of the program can be done by the scheduler time. Okay, here CPU is whatever the programs we have given. Here for example 1, 2 programs, 3 programs I have given. These 3 programs executed These three programs. OS selects the programs and send to the CPU for execution. Here CPU selects the jobs. Here CPU selects the jobs and executed in a manner. Here the execution can be done in four types of. The first one is the FCFS, is nothing but first come first serve. Next, SJF, shortest job comes first. Priority round robin. Here in FCFS, the programs are executed in a first come first serve. Next, in SJF, whatever the programs through the arrival time, based on the arrival time, that can be executed, and the shortest job can be executed in a first. Next, in priority, based on the priority, we will execute. CPU will execute the priority programs. Next, round robin. Here in this round robin, the time quantum or time slice will be there. Here time quantum is 4 seconds. Within the time quantum only executed. Next, error detection and protection. OS detect the errors in the CPU and as well as in the input and output devices. Next, here whatever the program we are executed in that program, the errors can be detected through OS. The whole functioning can be done by the error detection. So that this is one of the service that can be provided by the OS. The protection. What is meant by protection? In multi-programming environment, one process should protect from another process. Next, coming to the next topic, system calls. Here, what is meant by OS? OS is nothing but it is an interface between the user and computer hardware. It is an interface between the OS is nothing but operating system. The definition of the OS is it is an interface between the user and computer hardware. Here the system call is interface between the user program and OS. Here user program and OS, the system call is there. Here the interface between the user and OS is system call is there. System call is nothing but we are calling to the system. Next, user gives the instruction to OS only by system calls. Whatever the user given the instruction, which we are given the instructions, that can be executed through system call only. Next, it is a programmatic way which a user requests certain services from the kernel of the OS. Next, here two types of modes are there, user mode and kernel mode. Here in this, when a program is executed in a user mode, it cannot access the memory and hardware resources. In kernel mode, it can access the memory and hardware devices resources. Next, context switching is nothing but the shifting of the program user mode to kernel mode or kernel mode to user mode. Here this is nothing but the context switching. The program is switching is nothing but moved from user mode to kernel mode or kernel mode to user mode. Context, it is nothing but a context switching. In the user mode contains programs is executed in a user mode. It cannot access the memory and hardware devices. For that, if you want to execute a program in user mode, the context switching will be helpful. Next, in this, whatever the program can be switched to kernel mode, that is called the context switching. In kernel mode only it can be executed. Next, the types of system calls: process control, file manipulation, device management, information request, communication. First one, process control. Process is nothing but program under execution. Program under execution. The controlling of the whole process can be done in process control. Okay, whatever the programs which we are executed, the whole functioning of the program execution can be done by the process control. In that process controls, we are using some system calls. These are the system calls. For creating a process, execute process, abort, exit, terminate, and memory allocation. These are all can be done in process controls, which we are used in process control. Next, file management. This system call is responsible for file manipulations. What are the file manipulations are there? Create a file, delete file. For creating a file, we are using create a file. For deleting a file, we are using delete a file. For opening, open file. For closing a file, close file. For writing a file, we are using write a file, read file, get attributes, set attributes. These are all the system calls which we are used in file management. And the next, device management. Here the process may need several resources to execute the resources such as CPU, main memory, secondary memory, IO devices, etc. If the resources are free, they will allocate it to the processes. Otherwise, the process have to wait until the resources are available. Here, P1, P2, okay. Here, the several resources are the CPU. Here, CPU is there. If the program is to send, if the program is to send to CPU for execution, and CPU is released P1, after execution of the program, P1 is released. Next, the P2 is waiting. Next, P2 program requests CPU for execution. Next, what happens? The OS selects the program P2 and send to the CPU for execution. After execution of the program P2, it can be released from CPU. Here, the system gets executed and released. Okay. Next, in device management, CPU, main memory, IO devices, etc. These are the some system calls are here we are used. Get attributes and set attributes. These are the system calls which we are used in device management. Next, coming to the next system call, information request. In this system calls that handles the information and transfer the data from program, user, program to OS. Whatever the information or data which we have to send, that can be sent through the information request. Here the user and OS, in between the user, program and OS, we need to send the data or transfer the data through information request. Here these system calls to be used. These system calls to be used. Get time, set time, get system data, set system data, get process data, set process data. These are the information request system calls. These three are the information request system calls. Next, what is meant by communication? In services, this can be in OS services also there. One of the service provided by the OS, communication is also there. Here communication is nothing but exchanging the information between the two processes is called the communication. It can be done in two types. First one is the shared memory, second one is the message passing. Here shared memory, through the shared memory we can send the request to process 1 and response from process 2 through the shared memory only. Next, message passing. Here direct message passing is there. In direct message passing, the process 1 sends a message to process 2 and process 2 access the message and reply to that process 1. In these system calls, in communication, we have 5 types of communications are there. System calls communication: data communication connection, data delete communication data communication connections, data delete. In system calls in communications, create a communication connection. First, creating a connection. Next, deleting a connection. Send and receive a message. Transfer status information. And attach and detach remote devices. These are the system calls used in communication. Next, references. Structures of OS. I referred Java T point. Next, in system calls, geeks for Greeks. These are the references. Thank you.